Number one, a simple random sample of 1,100 males aged 12 to 17 in the United States were asked whether they played massive multiplayer online role-playing games, which we're going to abbreviate as MMORPGs. 775 said that they did. We want to use this information to construct a 95% confidence interval to estimate the proportion of all U.S. males aged 12 to 17 who play MMORPGs. State the parameter our confidence interval will estimate. So when you're doing your write-ups for your free response, part A is going to basically be the state part of it. I mean, at least like the first part of it. You're going to be more in detail when you are writing up your true free response. So this question, it's like A through H. It's kind of all the parts of your state plan to conclude with a little bit of extra. So anyway, your parameter, you have to remember, parameter is always your population value. So in this problem, we're doing a population proportion because they're telling us that we have 775 out of 1,100. So that's a proportion, it's not a mean. And so we would, in order to describe what the parameter is, we would say it's the proportion of all U.S. males aged 12 to 17 who play MMORPGs. Don't forget, when you're doing your write-up, you have to write it in the context of the problem. So it's not good enough just to say, oh, it's the population proportion. You actually have to write it in the context of the problem. For part B, it says identify the conditions. So remember, this is going to go in your plan part of your write-up. Identify the conditions that must be met to use this procedure and explain how you know that each one has been satisfied. And so one of the components of your conditions that I just have forgotten to talk to you guys about in class is that you have to state, when you do your write-up, under your conditions, you also always have to state the random component. And you'll be able to find that in the scenario typically. They'll tell you how they got the sample. And so, you know, it says right away a simple random sample of 1,100 males. And so you've got that the SRS is stated, so you do have the random component that you need. You have to assume the 10% rule because they don't tell us how many people we have in the, you know, how many males aged 12 to 17 that we actually have in the United States. So I wrote a sample of 1,100 males aged 12 to 17 is assumed to be less than 10% of the population of all U.S. males aged 12 to 17. So with the 10% rule, it is, you know, it's acceptable to just say we're assuming that, or, you know, it's most probable that, yes, we do have less than 10%. But for the large counts, you do have to actually plug the numbers in and calculate it. And usually, you know, in chapter 7, we were just doing NP greater than or equal to 10 and N times 1 minus P greater than or equal to 10. But remember that P is our population proportion, and we don't actually have that. So we're going to be using P hat, which is our sample proportion. So we're going to do N times P hat. So we've got 1,100 for that, our N, and P hat is 775 over 1,100. And when you multiply that together, that's 775. Since you can plug in the calculator, or you will see that the 1,100s do cancel each other out. And so that leaves you with 775, which is obviously greater than or equal to 10. And then if 775 play the game, then that means that 325 do not play the game. Or if I did 1 minus 775 over 1,100, either way you look at it, you're going to end up with 325 over 1,100. And so again, those 1,100s cancel out, and it leaves you with 325. So you have met the condition because it's greater than or equal to 10 for both of those. And so those are the conditions that we have to talk about. So please don't forget to include random. So we've got to have random for all of our different scenarios, but we also need the 10% rule, and we need large counts anytime we're dealing with proportions. Part C, find the appropriate critical value and the standard error of the sample proportion. So in red there, I've described how I would find the critical value. It does say that we're doing a 95% confidence interval. That is important to point out. Okay, and so on my calculator, if I have a curve and I know that I'm at a 95% confidence interval, then I know that the middle piece is 95%, so these two outside pieces have to share 5%. So that would make this side 2.5%, and that would make this side 2.5%. So if I was just going for this little Z star right there, I would do the inverse norm of 0.025. comma 0, comma 1, and that would give me this negative z-score of negative 1.96. If I wanted to find the other one, which I don't really have to because they're symmetric, so I know it's going to be 1.96, but if I wanted to find the other side z-star, so like right over here, then this area that's below that z-score right there would be the 95% plus the 2.5%. So I would actually be doing 0.975 since I'm representing 97.5% to the left of that z-score. And so you would get 1.96 on that side as well. So our critical value is 1.96. Our standard error, our standard error is going to come from the standard deviation formula. But remember from Chapter 7 that the standard deviation formula for proportions is the square root of p times 1 minus p divided by n. But we don't have p. Again, p is the population proportion. We don't have that. So we're actually going to use the square root of p hat times 1 minus p hat divided by n. So I plugged in my p hat to be 775 over 1100 in both spots, and then we know that our sample size is 1100. And then plugging that whole thing into the calculator, I got a standard error of 0.0138. And again, we call it a standard error because we're using sample data. We would call it a standard deviation if we were using population data. But it's truly the same thing. It's just a standard deviation of the sample instead of, of this one sample that they pulled instead of the population standard deviation. So they've, renamed it, and now we call it the standard error. So now using what we just did in Part C, we need to give the 95% confidence interval. So remember for that, most basic, for any confidence interval, you're going to start off with point estimate plus or minus margin of error. For this section, we're only dealing with proportions, so our point estimate is p hat. The margin of error is always going to be the critical value times the standard error. Okay, so our p hat, is 0.7045 because that does come from the 775, it comes from the 775 divided by 1100. That is our point estimate. Our critical value, if we're doing a 95% confidence interval, we know from the previous problem, Part C, that you would get 1.96. And then again, for the standard error, we got 0.0138 from the previous. And so when you type all of that into your calculator, 0.7045 plus 1.96 times 0.0138, you do get the 0.732. And then when you run it again with the minus sign, 0.7045 minus 1.96 times 0.0138, it'll give you the 0.677. So this is the 95% confidence interval. We also learned during the lesson that you can use the calculator, kind of a little legal cheating method, to find the entire confidence interval without having to do any calculations of critical values or standard errors or any of that. Remember that you'll go to Stat, over to Tests. We want to do alpha A to bump us down to the 1 proportion Z interval. Our X is going to be how many successes we have. So that would be 775 because that's the number of males out of our entire sample that actually played the MMORPGs. N is going to be our entire sample size. Confidence level is 0.95 for this problem. And when we calculate it, we can see that we do get the 0.677. And actually, I'd probably round that up to 0.678, the way it's showing from the test, and then 0.732. So I have written in green here, the practice answers are wrong, in my opinion. Both ways that I worked it out, I do not get the answers that the solutions provided for us, but I did notice that they wrote down the wrong standard error. They did not use 0.0138 as their standard error, so they probably had a typo somewhere, maybe a copy and pasting problem, but I feel like the answers are wrong, that this is the correct answer for this problem. And so I'm going to carry out my problems with the correct interval instead of using their answer. Okay, and so this, and by the way, I'm going to go back and just talk about D for a second. In Part D, that would be the work that you would show under the do part of your state plan do conclude. And so this last part, interpret the confidence interval, this is what you would write up as your conclusion. So if your state plan do conclude, under the conclude part, you would write, we are 95% confident that the interval from 0.677 to 0.732 contains the true proportion of all U.S. males aged 12 to 17 who play MMORPGs. So you definitely want to go back and write in the context of the problem always. Even if it specifically does not tell you to do that, your conclusion should always be back to the context. So notice that, we're talking about the males, we're talking about the games they play. That has to be written up in your conclusion. Okay, so I'm going to go back to the notes for a minute, the PowerPoint notes, before I talk to you about F. I know in 6th period we were able to talk about these slides a little bit, and in 8th period we didn't have the time to at all. So I just want to kind of talk to you really quick. I think this slide, nothing about it is new. Margin of error, we know that you find from the critical value times the standard error, and you get the critical value from Z star. You know that you get the the standard error from the square root of p hat times 1 minus p hat over n anytime you're dealing with proportions. Okay, so because the margin of error involves the sample proportion p hat, we have to guess the latter value when choosing n. There are 2 ways to do this. So sometimes they're going to give us a problem. They're going to be like, okay, we want the margin of error to be at least, or no more than 3%. So what sample size do I need to keep my margin of error at, around 3% or less than or equal to 3%? Sometimes you're not going to know a proportion. You're not going to know a sample proportion at all. You'll just have a sample, you'll be solving for the sample size. You don't know a proportion. It's like, well, what do you do? Well, they tell us to go ahead and use the proportion as 0.5. Just kind of make a guess, and that's just if they don't give you a proportion, just use 0.5 every time, kind of just a rule. They say the margin of error is going to be the largest when you have a success of 50% and a failure of 50%. So you're splitting it down the middle is going to give you your largest margin of error. So it's like you're kind of maximizing your error, if you will. So if going with 50% is your safest bet to go, if they don't give you a proportion. You'll see on the practice worksheet, the problems that we do there, that we're actually going to use the proportion given because we know that 775 out of 1,100 is our proportion, so we can use that. But again, if they don't give you one, then make sure you use 50%. So that's kind of just restating that. And so they give us an example. I'm going to read down to the bottom. There's some late company doing something, but I'm going to read down here. She decides that she wants to estimate to be within 3% at a 95% confidence level. How large of a sample is needed? So with this problem, we don't really know anything. If you kind of take a second and read the scenario at the top there, we don't know the proportion. But she wants us to be able to tell her what sample size she needs. And so we're going to maximize the margin of error by saying, you know what, we're going to use our p hat, and we're going to say that it is 50%, okay? We don't know the sample size. That's actually what we're solving for. We know the margin of error is 3%. We're going to use that as 0.03, okay? If we have a confidence level of 90%, then we do know our Z star. We have found it previously. If it's 95%, then we do know that our Z star is 1.96. So remember that you can get that by doing the inverse norm. And you can either do it of 0.025 or you can do it of 0.975, because remember you're adding in the tail, and that is where the 1.96 comes from. So when we're looking at a margin of error, she says she wants to be greater than or equal to 3%. We need to remember that the margin of error is the same thing as critical value times standard error. Okay, margin of error is the same thing as critical value times standard error. So we're saying that basically we want it to be less than or equal to 3%. I don't have to worry about the inequality thing. It's easier if you just look at it as equal to, and you'll be fine. So if we do 0.03 for the margin of error, critical value of 1.96, and we don't know a whole lot about the standard error, but we do know that we can use the formula p hat times 1 minus p hat over n, and n is what we're trying to solve for. But since we don't know a p hat, we're just going to guess that it's 0.5. So again, if you don't know a p hat, just plug in 0.5. Again, it maximizes what your margin of error could be. And so that's why they go with that. When you do 1 minus 0.5, you're obviously going to get 0.5, and 0.5 times 0.5 is 0.25. So what I want to recommend to you right now is, as you're working the problem out, don't round. Just use your calculator either for storing or for writing it all in without actually calculating it till the very end. So we're going to do 0.03 divided by 1.96 equals the square root of 0.25 over n. So all I've done is just divided both sides by 1.96 so far. And then to get rid of the square root, we want to square both sides. Okay? And so at that point, I'm running out of room, we're going to have 0.03 over 1.96 squared equals 0.25 over n. And so I could multiply both sides by n, so that's going to get it out of the bottom here. And so obviously I'm going to be dividing both sides by that big ugly thing, okay? And so on the calculator, instead of doing piece by piece by piece on the calculator and rounding and messing up, which I did in class of 6th period, sorry, the reason we got a different answer in 6th period is because of my rounding. So you don't want to do that. I try to learn from my mistake there, but you want to do a fraction and put your 0.25 on the top, because we're trying to do this all at one time and not do any rounding. So let the calculator deal with all that. We're dividing by the fraction, 0.03 on the top, 1.96 on the bottom, and we want to square that fraction that's on the bottom. Okay, so I'm just calculating this whole thing right here with the 0.25 divided by this side over here. Okay, hopefully it's going to give it to me. That's why it's 1067.11, but we actually need to say that she needs 1068. If she had 1067, I know that's closer to the number that's given on our calculator, but if she had 1067, she would just barely not have enough. It would probably put her at like 0.031, as a margin of error, something like that. It would be just a little bit too much. So we need to always, regardless of what the decimal is after our number, even though it's just a 1, we do round up to the next integer. So we would say it's 1068. Okay, so now let's see if we can get to the worksheet problem here. So they're working it out just the same way I kind of showed. They do a little bit different math. Oh, you know what? Let me go back to theirs really quick, just because there's room on this slide. And let me show you the Mr. Schuster way of doing it. Let me see if I can grab that. So Mr. Schuster's notes, if you look on, well, I'm trying to find it, guys. Sorry, just a sec. Okay, Mr. Schuster's notes, if you look on 8.2, he has written in his little notes thing, sample size for a desired margin of error, kind of at the bottom of the 8.2 notes, and then he says n is equal to p star, but he really means p hat, times 1 minus p hat, even though it says star again, and then z star over m squared. If you want to memorize this formula, it will always work for you when you're dealing with proportions. So you could memorize this formula if you want. It is not going to be given to you on the AP exam formula sheet, okay? So it is one you would have to memorize if you want to use it, but it does work, and it's a lot easier. You don't have to do all the algebra and dividing both sides by and squaring both sides and all that fun stuff. So we would do 0.5 times 1 minus 0.5. The z star is 1.96. The margin of error is what the m stands for. You would put your 0.03 and you would square it. And this should give us the exact same answer. A little bit easier way of getting there. The problem with this method is you do have to memorize the formula. And there you go. So you get the exact same answer. So I'll show both ways on the practice worksheet problem. And here it is. So in purple is the Mr. Schuster way of doing this problem, and then all the red worked out stuff is the algebraic way of doing it. So it says, suppose you wanted to estimate the proportion of 12 to 17-year-old males who play MMO RPGs with 95% confidence to within plus or minus 2%. So that 2% represents our margin of error. Calculate how large a sample you would need. So again, the margin of error, you want it to be within 2%. And so you want your critical value times your standard error to be greater than or equal to 2%. And honestly, I probably have that wrong. It's probably supposed to be less than or equal to. So forgive me there. Doesn't really matter because remember, we're just going to use it as an equal sign anyway. So I wasn't really thinking too hard when I wrote that down. So as you're working it, don't let that stress you out. It's really not going to matter. We're not looking for a plus and a minus because obviously our sample size is always going to be positive. So it really does not matter. Just treat it as an equal sign and go on. Okay, so we know that margin of error, again, is critical value times standard error. So we're going to plug in the critical value of 1.96. Again, that's because you do have a 95% confidence level. And so our standard error is going to be the square root of 0.7045 times 0.2955. Some students at this point are going to say, where the heck did she get those numbers from? Because I thought we were just doing 0.5 and 1 minus 0.5. Well, we actually have a proportion in this problem, so we need to use it. Okay, and so remember that our proportion, our p hat, was 775 divided by 1100. And instead of writing out that fraction each time, I just went ahead and divided it out, and so it is 0.7045. I do believe that's the rounded version of it. Will be okay. We went enough decimal places out. We will get close to the same answer that Mr. Schuster got, doing it without rounding, okay? I tried it to make sure. So anyway, so we're going to do 1.96 for the critical value, square root of 0.7045 times 0.2955. Again, that 0.2955 is just from 1 minus the 0.7045. And then divided by n, and we set that equal to 0.02. And so in blue, what I've done is divide both sides by the 1.96. And then in green, you're showing that you're squaring both sides. Okay, so we're just trying to isolate the n. We're trying to get the n by itself. And so that takes me down to this step here. And in red, I had 0.2082 divided by n, because when you multiply 0.7045 and 0.2955 together, you do get the 0.2082. And then on the right side, we had the 0.02, the 1.96, and the squared. And then, of course, you don't want n on the bottom, so you multiply both sides by n, which takes us up here. And so we have our 0.2082 by itself now, but we didn't want that by itself. We wanted n by itself. So we're going to divide by all this ugly stuff. And so you want to plug, again, the whole thing in the calculator. Don't do it piece by piece. If you do it piece by piece and you do any rounding, then you are going to run into a problem. And I just messed up because I wanted to actually start with the fraction button, sorry. So we're going to do 0.2082 on the top, and then we're going to do another fraction on the bottom of 0.02 over 1.96. And guys, I do realize that the solutions that, or the PowerPoint, if you follow their algebra, they do it a lot different than I do, but I promise you, you get the same answer in the end, okay? So if you like their algebraic way of approaching it better, go for it. I like Mr. Schuster's way better, to be honest with you. But again, you're going to have to memorize his formula to be able to do it. So anyway, the way I just did it, you get 2,000. The way Mr. Schuster would do it, keeping the fractions just because, I'm going to do 775 over 1100. So right now I'm just typing in what's in the purple. 1 minus, because that is the Mr. Schuster formula. And then we want to multiply by critical value on top, margin of error on bottom. Remember that they changed it this time to a 2% margin of error. And so now you only get 1999.18 or whatever. Doesn't really matter because either way you round up to the next integer. So his would also round up to 2,000. So we need a sample size of 2,000 for this problem. Okay, if you wanted to have, let's see, if you wanted to have a margin of error of still plus or minus 2%, but now instead of a 95% confidence interval, now you want a 99% confidence interval. Would your sample have to be larger, smaller, or the same size as the sample in Part F? Explain. I just went ahead and worked it out. I mean, we have enough information. You can work it out, plug the numbers in, and see. So all that's really going to change in this situation is your critical value. And so changing your critical value, instead of it being 1.96, now it's going to be 2.58. I just reworked the whole problem the same exact way, and doing it the Mr. Schuster way. All you have to change is the 2.58. So that's kind of nice on the calculator. You could just do second enter and just go change that 1.96 to the 2.58, and you should have my new answer. So that's why it's 3,465. That would be 3,465 would be the sample size we need. So that's obviously larger than the 2,000 from the previous problem. Okay, and I think this is our last problem. It says this poll was conducted through email. Explain how undercoverage could lead to a biased estimate in this case, and speculate about the direction of this bias. So you're conducting the survey through email, so the people who are going to answer you are online. And so you're going to have undercoverage of the males who are not online. They're either not online or they're rarely online, and so they don't answer email, which means if they're not online, then they don't really have the ability to play the game. And since it's an online game that you're asking them about. And so really you're probably going to have an overestimate. So what I wrote is there may be undercoverage of males who are not online much or at all. So the bias may be an overestimate since responses are coming from males who are online. If you are rarely or never online, then you don't have access to online games. So basically everyone who's answering them has a higher probability of playing the game because they're online. People who are not online, there's no chance that they're playing the game. So that's how I feel like you're going to get an overestimate from that undercoverage.